Unmute your speaker. All right, I got it.
Somebody has to draw that
Very rich person.
political argument.
No, this is a famous comic strip writer. Thank you. All right, here we go. So Richard already spoiled. He said, "Hey, we're doing percentages this chat." Yes, we are. I'll just say percentages are pretty easy in the sense of what to do. It's the doing it that usually gets people in the problem. There's long division involved. That's the challenging. It's also a lot of stuff. Today we're going to do one of many things. But in general terms, percentages is like a recipe. I'm going to show you how to do it. You write down the recipe. It's on your resource card for the test. It's like no big deal. Some of you will have it memorized. Others of you will not have it memorized, and that's perfectly fine. I don't care whether you memorize the formula. It's a procedure, or you have it on your resource card. Either one works great. All right. It's snow day yesterday, so we'll do three sections this week. I'll do a review on Monday. We'll take a quiz on Tuesday, and well, you can see how it rolls.
Is there like a chapter that's like really long?
Chapter 10 is your area and your volume stuff, so it's long only because, generally speaking, it's I want to say we counted up one time. It's 22 formulas you have to have memorized, right? I think it's 22, something like that. So luckily, I don't make you memorize anything, but that's 22 formulas you have to have on a resource card. That's why chapter 10 is. Oh, we're about to do chapter 9, but chapter 10 is the only chapter where calculators are used, right? Like, well, I'll say every day, bring your calculators. For those of you that have calculators, just bring them in. For those of you who don't have calculators, I will write the test, assuming that you will have a calculator in your hand, and no, I will not give you a calculator. If it's, during chapter 10 one day, and you're like, I forgot my calculator, I will hand you a calculator. But when we get to test day, I'm not handing out any calculators. Your job, part of the packing list for the school was you had a calculator. I don't care whether it's an expensive calculator this year or a cheap calculator. Either one's fine. Until you get to Algebra 1, you don't have to have the expensive one. If you have not bought a calculator at this point, then ask around. Who's got a cheap one for me? You don't need the expensive one. Don't go out buy a $100 calculator for course 1 work. We don't need that until Algebra 1. Chapter 10 test.
Will that be like over a month?
It'll be a month from now, yeah. All right, here we go. Here's your homework for tonight. Half of this lesson is ridiculously easy, and half of it is medium. And the medium part is only because we have to do long division. $14, $16, $18, $19 kids. 19's a good number. Is he in trouble?
He likes to wake downstairs because I don't think he wants to get
What? Oh.
All he has to bring is a notebook and a pencil.
Jake, put your mask on. Maddie, put your mask on. Danny, put your mask. Okay, everybody got the idea. Caitlin, you're part of that too. All right, here we go. Percents and fractions. Half of this is ridiculously easy. Half of it's not hard. It's just medium. All right. Of my other class, they listen always. I never get this issue. This is the class. Jake, I'm going to show you something today, right? You're going to do it the way I ask you, but you can certainly ask the question, why isn't there an easier way? And I will answer that question. But I first need you to do it the way I'm going to show you. Yes? Right? And then I will explain why you got to do it this way to answer your question, well, that seems stupid. All right, I'm just heading it off in the past. All right, here we go. All right, today we're going to be dealing with this sucker right here, which means what is a percentage?
A number.
Well, okay, it's 14.
What percent of?
What does that mean, though?
How much? It's like a fraction.
We use this all the time, right? You watch anything, sports, business, real life, your mom, your dad, right? Money. You always hear this thing called percent. What does it mean? Oh, by the way, you use it all the
Out
time.
of how much time something is done, how much time it's done successful. That's basically,
Out of what?
I don't know. Out of how much time you do
I heard it
something.
over here.
Out of 100.
What'd you say, Maddie? It's a number out of 100. Now, they don't say that, they say compared. Write this down, box 1A. Grab your pencils, let's go, right? Box 1A. When you talk about a percent, you're saying, how much do you have out of 100? Now, why do they choose 100 and not 10? Why do they choose 100 and not 40 or 50? Well, that's kind of been lost to history. Why do they choose a number out of 100? It could have been out of 40. It could have been out of 50.
Would it have been easier if it was?
It would have been easier if it was smaller numbers out of 10, certainly, but it's not that much more harder.
But if it's out of 100, in the back there's a percentage like 23, 25%.
Yeah, how about we do front first and then we'll talk about the back. All right. So a percent is defined as a number compared to 100, and the comparison is going to be division. And you can kind of see it in the symbol. That looks kind of like a division symbol. And I have 2 zeros, right? 100 has 2 zeros. So maybe that's why they chose that symbol. It's kind of a debate amongst mathematicians. And also it's a debate, why out of 100 and not out of 10? It could have been out of 10. All right. Here's one example, right? By the way, the word itself literally means percentum, right? Latin for 100, right? So out of 100.
Well, that's probably why.
That's why they chose the word, but I'm saying, why couldn't it have been out of 10 per deca, right? Instead of percent.
Maybe it's money related, how you have to have 100 cents to get a dollar.
Yeah, but remember, there were other civilizations where 100 wasn't used, right? But yes, this one has taken over the world and everyone uses percent now. All right, here's an example. In the 8th grade, there's 40 boys and 60 girls. Therefore, there's how many kids in the class? Well, then it's easy to do a percent. So what's the percent of boys in the class?
40%.
What's the percent of girls in the class?
60%.
Like 3 people have to sit at a desk.
That is,
It's probably like
yeah, that's what it says.
2 to 3 per class.
Oh, that would be a college class. Large college class I ever sat in was about 300 people in one class.
That's not real.
Right. That's usually freshman year, you take a couple classes that are like that. All right. So if I were to consider the boys to the class, there's 100 kids in the class, there's 40 boys, so 40%. Literally, that's where percent come from. It's a number compared to 100. So what was the girl percentage?
60%.
60%. And the total, right, if it's everything, has to be 100. All right. We're going to do 2 games today. The first one is I'm going to give you a fraction. You're going to write that fraction as a percent. And guess what the other game is? Percent to fraction. The second one is ridiculously easy. The first one is medium. Okay. There are 2 methods that the book shows. I have used these 2 methods over my life. I prefer method number 2, but that's my choice. Period number 1 said method number 2 is one that they liked as well too. You get to choose which one. I will give you, because I think it's a worthwhile endeavor, I will give you, typically I only say, hey, here's one technique. I'm going to give you 2 techniques. You can choose tonight for homework for the rest of your mathematical career, which one you want to use. Either one is fine. All right, but I'm going to give you a fraction. You're going to do some magic. You're going to turn it into a percent. And I'll teach you the magic here in a second. The second game is just the reverse. I will give you the percent. You will do some very easy magic and turn that into a fraction. All right, here we go. So to turn a fraction to a percent, very easy, as long as the number in the bottom is 100, yes? If the number on the bottom is 100, what's the percent? It's the top number with a percent symbol. If the fraction that I give you is out of 100, you simply write the top number with a percent and you're done. There's no work involved. So what's the problem?
These aren't.
the bottom number won't be 100, right? But if the bottom number is 100, well, there's really no work involved. Top number with a percent symbol. Everybody got that? Not on these. But guess what? 99.9%, haha, get it? Percent of the time, the bottom number will not be 100. So, but if the bottom number is 100, then you're right. So the big but here is that, well, the bottom number is not going to be 100. It's going to be 70. Hold on. Don't look. Cool your jets, right? If it's 70, we need a new technique. And this is also to head off the pass for the smarty pants out there to say, I know an easier way of doing it. No, you don't. What happens if the bottom number is 70? So I'm going to show you a technique. Yes, as you look at the paper, a lot of you are saying, I know how to do this really easy. But what if the bottom number, it can't be easily converted to 100? I'll show you two techniques. You can choose whichever one you like. You will do both of them, practice, and then you can pick which one you want to use for homework. They're both about the same. Some people would argue that the second one looks faster. They both involve long division, and that's the slow part of the process. Okay? All right. So I will show you two techniques how to convert this fraction into a percent. We're going to write down the steps first. So two techniques, box 1B. This is the first technique. I've had a name to it. It'll be called the proportion technique. All right. So write the steps down. Usually I write the steps for you. Today I'm going to force you to write them down. All right, step number one is you write a proportion. I'll show you how that's done here in a second. You take the fraction and you write this special proportion. The reason why this is a popular technique is because everyone remembers how to solve a proportion. Once the proportion has been solved, you put a percent symbol and you're done. So it's 3 easy steps. The other technique has 3 easy steps as well too. And if there's a challenging portion to it, it's step 2. The step 2 is, generally speaking, you gotta do long division. All right, Jake, give me the 3 steps. Read off from your paper. Get the point I'm making? Okay. All right. So once again, it's just 3 steps. Some of you will like this. Some of you might not like it. That's fine. Wait till the second technique to decide which one you like. Step 1, write a proportion. Step 2, solve the proportion. Step 3, you attach a percent symbol. So I generally, when I teach this, use nice, easy, friendly fractions so that the math is easier so we can do a bunch of these. All right, watch me. Hey, here's a fraction. Step number 1 said, it said write a proportion. So here's the proportion. Proportion are 2 fractions with an equal sign in between. I got 1. The second fraction will always be equal sign variable over 100 because we want to turn this into something over 100. That's the definition of percent. Once you have your proportion set up, you do cross multiplication. Not cross reduction, cross multiplication. Remember the butterfly method, right? So to solve the proportion, you multiply those 2 numbers together, and that is supposed to equal the other wing of the butterfly, right? Or however you want to think about that, right? 20 times n. Well, that's easy. What's 3 times 100?
300.
What's 20 times n? Yes, you do. 20n. Hey, you just took a test on this. Next step.
Divide
Both sides by
20.
20. Okay. Now we do long division.
N equals 15.
Chop the tree down. We get 300 on the inside. We get 20 on the outside. Put the decimal place immediately to the top. Always. Does 20 go into 3?
No.
Okay, dash or 0. Does 20 go into 30?
Yes.
How many times?
1.
1 times 20. Subtract, and we get, bring down your 0. 20 to 100. Are we done? There's nothing. We're at the decimal. So we solved it. We got 15. We got n equals, and the variable, you can pick any letter you want. What was the last step?
Oh, the 15 sign.
Put a percent symbol and you're done. Like literally. That's it. That's the whole process. Okay, it's 3 steps. The only pain involved is long division. Okay?
Remembering it.
All right, so this is technique number 1. Like I said, period 2 didn't like this technique once I showed the other one. Well, let's do one. And no, I'm not trying to say that this is the better technique. Both techniques are the same. 9/10. Jake, step 1.
Write a proportion.
The proportion will always be equal symbol, x over 100. The book uses n for number, right? But it will always be the same proportion. You just put equals, variable over 100. You're turning this fraction into something over 100. Doesn't. Cross multiply. 9 times 100 is, and 10 times n is,
And 10.
and 10 or 10n. Okay? And by the way, this math will always be the same. The next step will always be the same. What are you going to do?
Put them together.
You're going to get n by itself. And by that, I'm going to mean you're going to
Divide.
both sides by,
10.
okay? All right, do we need to do long division for this one? Sure. 900 divided by 10. I always move the decimal place immediately to the top. Does 10 go into 9?
No.
I always put a 0, but you don't have to. Does 10 go into 90?
Yep.
I will have people say that the answer is 9. Because I got a remainder of 0. And the reason I put this decimal immediately to the top is so that you can see that you're missing a number here. I still have to say how many times does 10 go into 0.
0.
So what's the answer?
90.
And then the last step is, okay, pretty easy. All right, who wants to be the smarty pants? All right, tell me, Connor, why your method is way easier than my method.
Well, I mean, it does work on a reflection, but for this one, you just add a 0 to them.
When you add a 0, that's really doing what mathematically?
Nothing. 10.
Say it, somebody.
You're multiplying by 10.
You're multiplying by 10. So yes, and Connor, you said it correctly. Connor said, it's not going to happen all the time. I don't teach this, although I am literally showing it to you right now. I don't teach this. But hey, if this number can be easily turned into 100 by, in this case,
10.
multiplying top and bottom by 10, then
But
go
if you
for
put
it.
a 7 down there, then that's going to be a problem.
Did you steal my slides and already look at them?
Yes.
Okay. So yes, his point is valid, but if the bottom number, oh, by the way, period 1, another smarty pants said, oh, just multiply it by 2.5. He was right. And I said, what about 41? And he said, okay, I see your point. All right. And the point being is that, well, if the bottom number isn't easily converted to 100, then that technique kind of falls apart. So I'm always about being, a mathematician, being efficient, lazy, right? Let's just remember one technique. So my technique that I'm offering you is make a proportion solver. Okay? But a lot of smarty pants out there will say, I can keep 2 techniques in my head. That's cool. So if the fraction can be easily converted to 100, well, then do that. Okay. But if it can't, well, then you need another technique. And I'm giving you 2 options for that one technique.
Well, you can multiply it by 2.5 today.
This particular one, and I'll make it 41 and then you're lost.
Yeah.
Okay. So method number 1, write a proportion. So remember the proportion will always be equals
100 over then,
some variable over 100, and now we multiply. The other thing is most people realize that all proportions is always this times this divided by that, right? Sometimes that can speed up the process. If not, then just solve it normally. 17 times 100. 1,700, and 40 times n is 40n. All right, this particular one, because we got to do what to both sides now? Okay, this particular one requires some work. So 1,700 divided by 40. I put my decimal place immediately to the top. Does 40 go into 1?
No.
Does 40 go into 17?
No.
Does 40 go into 170?
Yeah.
How many times?
4.
4 times 40?
1,600.
How about 160, not 1,600? And I'm saying this is why you're going to claim the answer is 4%, and it's not 4%.
40%.
Okay, we subtract and we get 10, bring down to 0, now it's 100. 40 goes into 100, 2 times 40,
80.
subtract, bring down to 0, 40 into 200, and I believe we're done at that point, correct?
Yes.
Okay, so what do we get for an answer?
42.
And this is why I like my zeros, because I'm never going to make a mistake. So we get 42.5, last step. So therefore the answer is Now, occasionally I have kids will say something like, it'll say, write your numbers as a percent. They'll say, well, this is a decimal. This isn't a decimal, it's a percent. It's a percent that has a decimal, but it's still a percentage. Okay? Tomorrow we'll convert decimals to percents and percents to decimal. And I'll have kids that will look at this and say, it's already a decimal. No, with a percent symbol, it's a percent or percentage.
Is converting it to decimal?
Oh, it's a really easy class. You just have to remember which way to go.
So this is the like the harder version of it than normal. Why am I going decimals first?
You mean fractions first? I don't know. That's why our book teaches it. We could do either one. I don't think that there's, I believe the reason why they teach the fraction first is because since the definition of a percent is
I
a number out of 100, it's already a fraction. That's kind of why you would do fractions first. All right, box 4, do it by yourself. Anybody lost, needs help.
Yeah.
Put an equal sign, x over 100. Put an equal sign, x over 100. Hey, do your work, Maddie. You just asked the question. Put an equal sign, x over 100. Cross multiply. 2 times 100. And 25 times n is 25n. Divide both sides by. Okay, so we got to do some long division. 100 divided by 25. Oh, wait, I can do that in my head. No, it's 200. Sorry, not 100. 200.
No, that's easy enough.
I agree. Does 25 go into 2? Nope. Does 25 go into 20? Nope. Does 25 go into 200? How many times?
8 times.
8 quarters would be $2. Therefore, 8% is the answer.
I actually got that.
Good. Technique number 1, proportion technique. Yes. Remember for that one, right? Yeah.
What about
But as soon as I make that 26, then you're out of luck,
what
right?
about mixed numbers? And
We're doing that next.
and then I was gonna ask you what the other different.
We'll do that next. All right. Are we good?
Yeah.
Devin said, hey, this was also an easy one. We could easily turn that 25 into 100, multiply top and bottom by 4. Just remember, right? If that's the only thing you remember, you're out of luck as soon as I change that 25 to 24 or 26, which I will, right? This way you only have to remember one technique. Now, if you can handle more than one technique, then absolutely throw that one in your toolbox because, boy, that makes this one easy. Maddie? Will always be what? Yeah, for the proportion. Yeah. Because remember, that's the definition of a percent, something out of 100. What we're really making is an equivalent fraction here. Yeah.
So this is the first one. It's probably gonna be the one I really remember.
I will just say I looked at the homework and most of them are pretty friendly numbers. All right. Connor's question is, what happens if we have a mixed number? All right. Connor was not here in person for those classes. I don't remember if you remember on the videos how many times I said, if you ever have a mixed number, what should be your first step?
Turn it into a which we call
Turn it into an improper fraction. Yes, you can add and subtract with mixed numbers. No, you can't multiply or divide with mixed numbers. All right. So if we're about to put this, doing some multiplication, we need this as an improper fraction. All right, Nathan, stop passing notes. Okay, here we go. Do you remember how to change an improper fraction, Grace? How do we do it?
2 times
Bottom times middle,
and then
add the top, all over, and I call this making the circle, right? Circle method, right? Making a clock, right? 2 times the denominator times the whole number plus the numerator all over the denominator. Oh, by the way, what do we get for an answer? 3 over 2. So that's the fraction that I need to convert into a percent. All right, no big deal. Set it up as a proportion. Talk me through it, Jake. Go. Okay, so what do you want me to write? So a proportion has 2 fractions with an equal sign. So you said put an equal sign. Okay, what's the other fraction? Write this in your notes. The fraction will always be, always a variable over 100. It will always be a variable over 100. The book always chooses n. If you want it n for number, right? But you can choose any variable. All right, Jake, tell me what part of that was confusing. Yeah, but I'm saying it's never going to change, Jake. It's always going to be x or n over 100. Does it ever change? No. Therefore, what's confusing? Okay, good. Now what, Jake? Okay, absolutely 100%. How do we solve a proportion? Cross multiplication, butterfly. Write that down. Something in Jake's speak that helps you remember that. Okay, I gave you my words, but maybe that's not helpful. So something that tells you, hey, I need to multiply the cross products. Top left times bottom right.
So 3 times 100 is 300.
Okay,
2 times n is
2n, right?
2n.
Okay, all right, there you go. Now, once again, I'm going to ask you to pause. You said you couldn't remember it, so then now we need Jake's speak. We need something that helps you remember that. I gave you my what I would say.
300 is equal to 2 times n.
So now we got a one-step equation. We got to get n by itself. What's attached to it?
A variable.
How? No, n is the variable. What's attached to n?
2.
How?
Multiplication.
How do we get rid of multiplication?
Division.
What are we going to divide both sides by?
2.
Okay, and this is what I did not see on your test paper was this right here, right? From here, I need to see that, and now you can do scratch work off to the side, which I did see on your paper. Saw the scratch work. I need to see that. And conversation we had on Friday about, hey, well, as soon as this gets harder, you don't know how to do that one step right there. You can't solve it next year because we're going to be doing 4 and 5 step equations next year. You got to be able to do that individual tiny little step and then 4 other tiny little steps. Okay, 300, can you leave that in your head, Jake? 300 divided by 2. If you divide by 2, what are you really doing?
Splitting it in half.
Yeah, what's half of 300?
150.
So you can do it in your head, right? Okay, this is the algebra, but if the numbers were friendly. Okay, last step. What's the last step? It's on your paper.
Attach the proportion.
Percent.
Oh, I'm sorry.
Is that what it says on your paper? Well, that's what it will say.
Yes, that's what it says.
Okay, so what's the answer?
I can't see.
You said it was 150.
Right.
So what's the last step?
Attach the percent.
So what's the answer? What's the last step? One more time. Just read it.
Attach the percent.
It just literally means put a percent symbol on your answer.
150%.
So once again, Jake speak because you didn't get it from what I said. Something to yourself to tell you what you need to do. And I'm just going to claim easy or hard, the whole thing. Procedure is easy. What's the hard part?
Right, solve attach.
Well, the solve part is because it could sometimes involve long division. This one was easy because we're dividing 300 by 2. But if it was 300 divided by 7, well, then we're off to the races with some uglier math. Be ready for it. All right. Am I correct in assuming that we got this? Maybe Nathan, you weren't here for all of this?
Yeah, but I'm good.
Okay, good. Nathan, you missed the speech where I said, I'm going to show you 2 techniques to do this one thing. So there's flavor number 1. If you like that, and that's good enough for you, it's good enough for you.
I'm right back.
There is another technique. Like I said, period 1 liked it. I don't know why, but they like this second technique better. Technique number 2 is, if you've noticed, every time I hand you back a test, do I ever put your grade on it?
No.
What do I put on your test?
Percentage.
I never put a percentage.
Fraction.
I put a fraction, and then what do I say? I say, well, calculate your percentage. Duh, that's literally what we're doing today.
Top number divided.
Yeah.
Give me something to throw at her. All right. All right. But yes, literally, I've waited until the end of January to formally teach you something I've asked you to do throughout the year. Now, for those of you who've been paying attention, you've already used method number 2, because this is how I always tell you, hey, when you say, I don't know how to convert a fraction to a percent, this is what I always tell you. So write this down, please, box 6. This is option number 2.
Did I spell decimal?
No, thank you. By the way, I've used these slides for 3 years and no one has noticed until now.
A
Congratulations, Connor. All right. Change the fraction to a decimal.
I love decimals so much.
Step 2. Oh, I spelled it right that time. Move the decimal 2 places to the right. I said it has the same number of steps, and step number 3 is add a percent symbol. All right, there, now it's perfect. Oops. All right, those are the 3 steps. The method number 1 took 3 steps. Method number 2 takes 3 steps.
Actually, I like my flip one better. Yeah.
You haven't even seen us do this.
Just like
All right, Danny.
like the first set of step things. Is it the same as the first one was like bigger? Like it's 50 whatever 30. Like
Oh, it's yeah, it doesn't change. All right, so let's see how this works. So here's my fraction. So step number 1, it says convert to a decimal, right?
A decimal.
You spelled it right though.
I know. To a decimal. So unfortunately for you, this technique also involves long division.
Short division.
All right. This one is short division because it's pretty easy. Okay, you chop the tree down, 7 falls on the inside, 10 falls on the outside. I put my decimal immediately to the top. Does 10 go into 7? I put a 0. Add a 0. Does 10 go into 70?
Yes.
I think you can see that that would be 0.7. So it still involves long division. Other technique, you would still be dividing 10 into 7. Okay. The only difference is now step number 2 says you move the decimal place twice. Well, there's only 1 0 here, so we need to add another 0 before we move it twice. You also need to remember which direction to move it. If you move it to the left, you get it wrong. But if you can remember, move it to the right 2 decimal places, you can get to the answer. Now, notice it looks like less work. It's the same amount of work as technique number 1. Some kids are like, yeah, but you got to write equals x over 100, and then you got to figure out what you're multiplying. And they're like, I will say, in generally, it's the same amount of steps. It still involves long division. Yeah.
Do you get extra credit if you use both of these?
No.
Aw.
All right. One more time. Oh, by the way, no, we're going to do this together. Grab your pencils. Let's do this technique once. Now, I gave you a nice, easy, friendly one. It's not that hard to do. Step number 1. Well, you got to convert it to a decimal, right?
Decimal.
So I had to convert it to a decimal. So it's long division. Grab your pencils, everybody. Let's do this. We chop the tree down. The 4 doesn't fall on the inside. The 3 falls because the tree falls to the right. So it's correct. 4 falls on the outside. Put your decimal place immediately to the top so you don't forget it. Does 4 go into 3?
No.
0. Add a 0. Does 4 go into 30?
Yeah.
Add a 0. Does 4 go into 20?
Yes.
So what's the intermediate answer?
0.75.
0.75. And many of you, myself included, this is why I use this technique. Okay, I'm going to show you the technique. Most people just move the decimal place right here. They don't literally rewrite it and then move the decimal. This is why a lot of people like this technique, is because you can get the answer from the long division, right? Move the decimal place twice.
Don't you get the answer for the other one, long division too?
Yeah, but you still have to do that other step. All right. So there's the technique. I don't care which one you use, method 1 or method 2. Does everybody understand method number 2? Neither technique officially has a name to it. I'm going to say, from what I've seen in my experience, most students, by the time they get to high school, this is the technique, right? And just so before you guys ask, there is a percent symbol on many calculators. When you get the expensive calculators, there's no percent symbol anymore. It goes away. And it's because you're supposed to, by the time you get to high school, have a solid understanding of percents. You don't need a percent symbol. That percent symbol doesn't do what you think it does on your calculator either. You don't press it and it tells you what the percent is. Okay? It just changes a whole number into a percent. All right. So other students, because I gave you many options there, in fact, I gave you 3 options, will say, I'm confused. You showed me too much stuff. So I'm just going to point you back to the previous techniques. Pick one, whichever one you like, and ignore the other one. All right, don't think that I'm going to ask you for both. You can just pick whichever one you like. All right, remember, tonight for homework, if you have a mixed number, step number 1, you need to convert it to an improper fraction. Okay, half the class is over. The other half, I said there are 2 games. The second one is, I said it's the very easy one. Here we go. I can teach it to you in about 2 minutes. To change a percent to a fraction. You ready for an easy one?
Yes.
All right, here we
Wait, that
go.
was medium? That medium was pretty easy.
Write this down, please, box 8. These are the steps. Step number 1, to change a percent to a fraction. Step number 1, you take the number and you put it over 100. Step number 2, reduce the fraction, you're done.
Easy.
That's it. That's it. You're going to be given a percent.
Do you reduce it to the lowest?
You do reduce it.
To
You,
the lowest?
yes.
Okay.
You take the number, you put it over 100. In other words, you make a fraction where the number is the numerator, and 100, it's always going to be 100. 100's the denominator. Then you reduce. That's it. If you're lucky, it can't be reduced. Therefore, there's literally no math involved. If you're unfortunate, then it can be reduced. You got to reduce the fraction. Yeah.
So if you've got like, what percent? So if you've got like 50% and you put it over 100, it wouldn't be 50%.
It'd be a half.
It'd be like 5%.
It'd be a half.
But you can reduce that.
I did. 50 over 100 reduces to a half.
So if it ends up in a fraction,
It will always end up in a fraction.
so if you have 27% and you put it over 100, you have 27%.
We're not converting a percent to a percent. We're converting a percent to a fraction. So after you put 27 over 100, you reduce it and you're done. That one can't be reduced. You're done. I'm not turning a percent back into a percent. I'm just writing the percent as a fraction.
Okay, now I get it. Thank you.
Hey, here's the number. What's the number?
42%.
Put it over 100. Literally, that's step 1. I'm not making this up. That's as easy as it gets. You put the number over 100. Now, it leaves off the part where you drop the percent symbol, but that's kind of intuitive. Yes?
Yeah.
What goes into 42 and 100?
21. 21 and 50.
21 doesn't go into
Two.
100.
2.
2. So to reduce this one, we would divide the top and the bottom by 2. And that's going to give me 21 over. And you're done.
Oh, okay, that works.
I told you this one was easy.
That's very nice.
Who's lost in what I just did? All right. 25%. Step number 1. What do we do?
Put it over 100.
Put it over 100. Jake, what goes into 25 and 100? 4 goes into 100, but not 25.
Oh. Sorry.
5. Now, other people, Maddie, said there's another number. What's that other number, Maddie? Now, if you did not realize that 25, that is the GCF of 25 and 100. But if you didn't realize it, Jake said 5, perfectly fine number. And it just means you got to do this method 2 or 3 times. So let's go with Jake's. He said 5. So let's divide top and bottom by 5. 25 divided by 5 is, and 100 divided by 5 is 5.
Not 20.
20.
That I had.
But wait a minute, what goes into 5 and 20?
5.
So this just means you'd have to do the process twice. Or if Maddie said divide by 25, 25 divided by 25 is 1, and 100 divided by 25 is 4. So Maddie would have been done in 1 step, and the rest of us are working it through, but that's
Well,
fine.
you could just look at that and say, look, that's a quarter and put it over.
Now, some people have fluency with their fractions, and this particular one. have some fluency and they already recognize that pattern, sure, but just be careful, don't make a silly mistake. All right, box number 10, here we go. Step 1. What do we get? Then we ask ourselves, is there anything that goes into 33 and 100?
No.
No.
So guess what?
We're done.
You're done. Now, you don't have to rewrite it twice like I just did. But yeah, like I said, and I said this at the start, I said, hey, if you're lucky, they give you a number that can't be reduced with 100. Here's an example right here.
So this is a really easy one, and the one that was pretty easy was the medium.
That was the median. All right. This also works when you're over 100%. By the way, if there's one expression that really bothers me is when they say give 110%, right? You can't ever give 110%. You can only do 100%,
On the test.
right?
Yeah, it was really close.
Right?
Not that
Well,
bad.
bonus questions, then it's not out of 100%, right? If I make it a bonus point, then it's over 100%. But I'm saying just in general terms, human beings, right? You have
I can be made of
you can give you 100%, but that's it.
You have a people limit.
If you say that you can give 125%, that means you were slacking the first time when I said give 100%. 100% is everything you got,
Yeah,
like
no.
nothing more else. I'm giving you everything.
If you give 100% of your life, you
If
get
I have $10 in my pocket and I say give me 100%, you give me $10.
You know, you
If-
take your
If if that says something like, hey, give me 200%, that means that you're going to give me $20. You only got $10. You can't give more than what you got. Okay, you can have 200% of things, but you can't give more than 100% because 100% is what you got.
100% is maximum.
100% is maximum. All right, a whole bunch of people are not paying attention. However,
You're in chair.
we do have 125%.
Chair.
For instance, if you eat, I don't know, 4 apples one week and the next week you eat 6 apples, yeah, you just ate 150% more than the previous week, right? Or I'm sorry, you ate 50% more than the previous week. But in total, that's 150% different to the first one. Okay,
Said it doesn't go lower or 100.
right, but I'm saying if what you have is 100%, you can't give more than that. However, you can change.
But if you get more of it later, that changes.
That changes, right? Okay. So this particular one, once again, to change a percent to a fraction, you simply take the number, you put it over 100, and you reduce the fraction. Now you know that this can be reduced by,
25.
so top and bottom by 25 gives me,
I mean, you could reduce it by 5, 4, 5.
and the instructions will tell you to write all things as mixed numbers if necessary. So this one is
1 and
1 and 1/4.
Can you not divide it by 12.5?
One more time.
Can you divide it by 12?
What am I dividing by 12.5?
Both of them.
I can divide by any number that I wish, right? But if you want to reduce a fraction and be left with a fraction, by the way, remember we define as a fraction as 2, I haven't used the word integers yet, but I will next year. 2 integers, whole numbers, right? Compared with division. You can certainly have 7.4 over 3.1. This technically is not a fraction. You would have to multiply top and bottom by 10 and get 74 over 31. Now
So
that's
is
a
that
fraction.
decimal? This one's a whole. Yeah, but 25 divided by 12.5.
No, I don't say you can divide. I just said you can divide by anything you want as long as you divide top and bottom by the same thing.
We never got our tests.
I'm not going to hand it back until everyone's taking their test.
Oh, okay.
All right.
I mean, we're still at Facebook.
All right. Any online learners? No. But online learners, if you have any questions, go ahead and send me a chat or an email. Catch you guys later.